Good morning, students. Today, we want to continue from the last class. So we have understood the concept of energy, and now we want to solve some questions under energy. An object of mass 20 kg released from a height of 10 meters above the ground level. The kinetic energy just before it hits the ground is dash. Let's try to interpret the question diagrammatically. It said an object is released from a height of 10 meters above the ground. So, which means the object is at a particular height of 10 meters. So, this is the ground level. So, the object is at this particular height above the ground. The kinetic energy of that object just before it hits the ground is dash. In the last class, I told you that when this object is at this particular building, it possesses only potential energy, which is equal to what? mgh. This object only has potential energy at the top of this building, and it has no kinetic energy, which means the kinetic energy is zero. So when I release this object now, the potential energy continues to decrease because the height is decreasing. Because I need the height to get my potential energy. So if the height is 7, you get a lesser value for potential energy. If the height is now 5 at the midpoint, you get a lesser value for potential energy if you put your height as 5 here. So, and while the potential energy is reducing, what happens to kinetic energy? The kinetic energy now increases. It now increases because the kinetic energy is the energy possessed by an object in motion. So the object is now in motion. Now, before it hits the ground, the potential energy is converted to kinetic energy. That is just before it hits the ground. I have explained this concept in the last class. I'm just trying to revise. So the question says the kinetic energy just before it hits the ground is dash. So I have known that the principle is before it hits the ground, the potential energy will be equal to kinetic energy. So let's look at the parameters given in the question. We are given 20 kilograms. That's the mass of the object. We are also given height. But now, we are asked to calculate kinetic energy. What's the formula for kinetic energy? Equals half mv squared. What's the formula for potential energy? mgh. So we are asked to get kinetic energy here. Are we giving mass? The answer is yes. Are we giving velocity? The answer is no. But because in the question it says just before it hits the ground, I know these two are equal. So I can say potential energy equals kinetic energy. So kinetic energy can also be equal to my mgh, which is mass of the object, which is 20, multiplied by acceleration due to gravity, which is 10, multiplied by the height of the object, that's the height of the building, which is 10. So the answer here will be 2000 joule. If I like, I can convert it to kilojoule by dividing the 2000 by 1000. So anytime you have a value and you are converting to kilojoule, just divide the value by 1000 and you get the value in kilojoule. So the value of this in kilojoule is 2 kilojoule, or you say 2000 joule. Let's look at JAMB 2013. An object is moving with a velocity of 5 meters per second. At what height must a similar body be situated to have a potential energy equal in value with the kinetic energy of the moving object? So here is very simple. So in the question, it is being said that at what height, which means we are looking for height, of a similar body be situated to have a potential energy equal in value. So here we already understand that they asked us to assume that the potential energy of the body that we don't know the height, so and that potential energy is equal in value with the kinetic energy of the moving object. So we just say potential energy of the object we want to get the height is equal to the kinetic energy of the moving object. So this is the assumption given in the question, because without this assumption, we might not be able to get anything. So this assumption make it easy for us to get anything we want to get. So what is the potential energy? mgh. What's kinetic energy? Half mv squared. So ordinarily in the question, we're not given mass. So because we have mass on both sides, we can divide both sides by m. So if you divide both sides by m cancels out. So we say m goes here, m goes here. So we have gh equals v squared divided by 2. So what's our g? Our g is constant, 10. 10 multiplied by, we are looking for h. Just leave your h. Then we know our velocity from the question to be 5 meters per second. So we have 5 squared, don't forget this square, divided by 2. So if you cross multiply, you have 2 times 10 times h equals 5 squared is 25. 25. So 2 times 10 is 20. So we have 20h equals 25. Divide both sides by 20. So we have h equals 25 divided by 20. Then h equals what? So how many? So we can say h equals 1.25 meters, which is also equivalent to 1.3 meters. So, and that ends the question. Thank you very much. We meet in the next class.